Algebra 1, this video lesson focuses on Chapter 1.7, which is all about functions. This is the last video lesson that we're going to have before our next exam. And this chapter, or this section of the chapter, is full of vocabulary words that I need to make sure you know. So let's go through them one at a time. Starting with the word that's in the title, function. Hit the pause button, read this paragraph to yourself, and then I'll explain. Okay, I'm going to assume that you did that. And as the paragraph says out of the textbook, and this is the first paragraph of the whole textbook, of the whole chapter, a function's a rule. And it talks about a relationship between inputs and outputs. Sorry, I keep hitting the pause button because I keep being interrupted by announcements coming over the intercom. I think I was saying that a function is a relationship between inputs and outputs. I'm going to define inputs and outputs in a second. But the key point is this sentence right here. For every input, there's exactly one output. So I think of a function as being like a calculator. If I ask the same question, in other words, if I take the same question into a calculator, looks like there are going to be a lot of announcements for the end of Friday. If I ask the same question, a function should be giving me the same answer every time. Just like if I type a question into a calculator, it better tell me the same answer every time. If it doesn't, then the calculator is broken and I should throw it away. Similarly, any kind of relationship that gives me different answers depending on its mood is not a function. It's got to always give me the same answer for a particular question. So notice, if I ask question 0, I always get 3. If I ask question 1, I always get 1. If I ask question 3, I also get 1, but that doesn't matter. It's okay to ask two different questions that give the same answer. That's normal with a calculator, right? You could ask two different questions that come out with the answer 10. It's just the answer to your question, if it's question 1, had better always give the same answer to question 1. So I hope that makes it a little clearer. Let's now talk about inputs and outputs. By the way, functions are something we're going to come back to again later. So I'm not so focused on whether or not everybody has functions completely clear in their minds. We'll have more opportunity to talk about that. But we do need to talk about these two things, input and output. Okay, inputs are like the questions that I put into the calculator, and I put the word put in for a reason. Inputs, put in. And similarly, outputs are the answers that the function, just like a calculator, puts out. Domain, that's the set of all those inputs, all the things I put in the calculator. Range is the set of all those outputs. If I look at these ideas on an XY graph, domain is the set of all the X values. Right? Domain goes with X values. And we've started talking about in the past few classes the idea that your X values are your independent variables. And I know that most of you have already talked about that a fair bit, but I'll come back to independent variable in just a second. Your range is your Y values. And like I said, you've already done a unit in your science about dependent variables. Your dependent variables belong on the Y-axis. Let's remind ourselves of one thing though. Your range, like I said, go with your outputs. Your domain, go with your inputs. So these four ideas, input, domain, X, and independent, all go together kind of like a family. Just like output and range and Y and dependent go together. Let's look at an example. If I compared the relationship between amount of rain and tree height, the amount of rain belongs on my x-axis. It's that independent variable. The tree height depends, it's influenced by the amount of rain. The tree height belongs on the y-axis. It's the output of my experiment. If I conducted an experiment looking over the years at amount of rain from one year to the next, I would be expecting to see differences in tree height. The opposite's not going to be true. I'm not going to influence the amount of rain that comes out of the sky by how tall the trees are around me. So hopefully that difference, that distinction, makes it a little clearer which's independent and what's dependent. So here's that laundry list of vocabulary words. Hit the pause button, look it over, and make sure that you are clear on all of those terms. Okay, I'm not going to spend a lot more time talking about these terms for now, but you can always come back to this video and double check them. Notice I put function in parentheses, even though it's the focus of the chapter, supposedly, it's not going to be the focus of our discussion right now. We're going to come back to functions over future lessons. Instead, let's look at how we make use of this information. Now, example 1, right out of your textbook, ought to look very familiar. It's a very similar problem, figure 1 through figure 6, to those stage 1 through stage 6 types of examples that I gave you on your most recent quiz. And so you ought to be very comfortable making a table. They're now calling it an input-output table, but you ought to be very comfortable making a table from this picture. And then ultimately, we're going to get to making an equation. In other words, turning the pattern that we see here into a formula, effectively, for the pattern that we're seeing. But let's look at another example, even shorter and maybe a bit more of a stretch for you. Let's make sure that we understand. Hit the pause button and read this paragraph. Okay, I'm going to assume that you did that, and I'm going to remind you that the way we build a formula, or in this case we're calling it now a function, oops, my mistake, we're calling it now a function, is to look at the starting value. I talked about this a number of times, I'm going to keep talking about it. The starting value combined with the rate of change. And that word per there ought to be a tip-off that it's talking there about a rate of change. Combine those two ideas and you can put together usually a formula, or let's call it from now on a function. That's the relationship between those two concepts. So here's that function. Height, in other words h, or altitude if you want to call it that, is equal to the starting value 250 plus the rate of change times the variable that's changing. What's changing? Time. Time's going by. With every minute, I get another 20 feet in height. Add that to my starting place, 250, and I can figure out how high up I am. Now I've got to uncover one thing here. They mention that this is only true when time is between 0 and 5 minutes. This is my, excuse me, this is my domain. This is the set of all the x values that I'm allowed to use. Why don't I go past 5 minutes? Well, because I'm probably not going to keep putting hot air into my balloon after 5 minutes. I don't know a lot about hot air balloons, but I would assume eventually they would pop, so maybe that's the reason here. So our study is only going to look at between when you start the heat going into the balloon and 5 minutes afterwards. So now we've got 4 questions. First of all, calculate a number of different heights based on choosing some different inputs. So in other words, choose some different amounts of time and calculate some different outputs, some different heights that you get. Hit the pause button. When you come back, I'll show you what the textbook did. Okay, here's the textbook. It actually calculated it for 6 different inputs from 0 all the way through 5. And each time it simply plugged that value into the function and then calculated what the height was. So the range turns out to be from 250 feet up to 350 feet. The second question, oops, that ought to be highlighted here, is to organize that data into a table. And whoops. There, sorry about that. I just wanted to focus the attention on the table that you created from this set of data. So here are all your inputs that you, or in this case the textbook chose, 0 through 5, and the outputs, 250 through 350, organized here into a table. Now your third question is to graph the data that's in the table. So the textbook comes up with this graph right here. And all they've done is they've plotted each of these points. Here's a coordinate, 0, 250. The key point, though, in being able to draw the graph is to remember this is your independent variable, time, and this is your altitude, height. Height is influenced by time. Time's not influenced by height. So plot it this way, and you should end up with a graph that's the same as the one they have here based on this same set of data. Last thing then was, what's the domain of the function? And the answer, depending on whether you're looking at the table, if you're looking at the table, the domain, in other words the x values, well, there are only 6 listed here, 0 through 5, and you would list them off as a set, and that's the domain. If you're looking at the graph, though, the domain includes the spaces in between 0 and 1, and in between 1 and 2, and in between 2 and 3, and so on. So it's actually all the way from 0 to 5. So in other words, time is greater than or equal to 0, less than or equal to 5. Okay, last example in the textbook is example 3 about scuba diving here. But I'm not going to just repeat what the textbook says. I'm going to have you do some work with a new problem. I give you this question here about an aerobics class. I want you to answer all 3 of these questions, so go ahead and hit the pause button. And when you come back, I'm going to show you the answers to all 3. Okay, I'm going to assume you did that. Here's the equation. The price, the total price, is going to be equal to 3 times C. C stands for the class, so $3 per class, plus $10, that's the starting amount. The input-output table, oops, I guess it came from this end. The input-output table looks like that. Start with 1. If you go to 1 class, your price is $13. They've run their example here all the way to 10. If you take 10 classes, that would be 3 times 10, or 30 plus 10. 30 plus 10 is 40, and that's how they got 40. Here is that answer. I hope your input-output table looked a lot like this one. Last question was then to graph it, and here's that graph. And here's something interesting to me about the way the textbook drew this graph. Notice they are starting, the starting value they're saying is with 1 class. I would have continued this line this way and had it start from right there, because I can imagine a situation where somebody pays the initial membership and then never shows up for any classes. So I think it's perfectly possible that somebody would have 0 classes but still end up paying $10. So I think it should start there and continue upward. But basically your graph ought to look like the one the textbook has. One more to practice about the monarch butterfly. Hit the pause button, come back with the answers for A, B, and C. Okay, I'm going to assume that you did that. The formula this time, look, it doesn't have a starting value. It only has a rate of change times a variable. Why? Well, there's nothing in this sentence, rather. There's nothing in this sentence that talks about where or when the monarch butterfly started. It just says that it keeps going 80 miles per day. So if you want to figure out how far it's gone, you're not calculating it from a particular place. You're just saying 80 times t. Next thing then you were supposed to do was figure out the input-output table, and that's what the textbook came up with. You might have had 1 as your first input, and then 2, and then 3. For whatever reason, the textbook picked 2, and 5, and 8, and 10. So your input-output table might look a little bit different, but double check their values and make sure their values make sense to you. And then the last part of it was to graph it, and here's the graph they came up with. Interestingly, notice, for whatever reason, they've decided to start their graph from 2 days. Of course, it makes more sense to me, at least, that you start the graph from 0 days. Where and when does the butterfly actually start? The butterfly starts on day 0. No days have gone by yet, and the distance traveled at the very beginning. It's like the butterfly is still in its driveway. It hasn't gone anywhere yet. And then it continues up along this line like so. And they've decided to end it at 10. I don't know why either. I would imagine a butterfly can keep flying more than 10 days. But that's generally what your graph ought to look like. Okay, there's your homework, and I'll look forward to seeing you next class.